Welcome to this video, guys. We are going to be reviewing the paper 1 pure mathematics Edexcel paper that was done just yesterday. So, sir, take it away. What did you think of this paper?
As a whole, I would say that the paper is a reasonable paper. I wouldn't say it was that difficult. I would.
A lot of people commented that it was so hard. It was so hard. What do I
I
mean?
was going through it page by page, and I realized that all the questions are straightforward ones. They're not tricking you in any way. It's if you have a good algebra, if you're competent with algebra, you can actually apply your algebra skills and just solve the problem that are in front of you.
Okay.
It wasn't that tricky.
So, are you thinking as a teacher though, or as a student? Think as a student. What?
I'm thinking as a middle level student, having revised enough, knowing basically, having a good knowledge of all the topics, you can actually use that knowledge and access those questions and at least get most of it done if your algebra skills is good. It's like solving equations. You link the two equations, you solve them. If you have a good algebra, then you can solve any type of equation, having fractions or in any other forms, or even cubic or quadratics.
Yeah.
You can just, one of the questions said you have to show all your steps using algebra. It was solving a cubic one, hence long division involved. So if your algebra skills are good, then that paper I would say would be it's actually quite decent.
So it
paper.
was actually a decent paper, not as hard as people have made
That's
it out.
that's my opinion.
Yeah, your opinion on this. How do you think your students would do on this?
Hopefully I would say that they would have done well on this. It's just one of the questions at the end which I was quite disappointed with.
Which number is that?
It's the last one, question 16.
Oh yeah, you were mentioning that about the parametric.
Integration. It's like when we were revising, like when that similar topic came up, I was
Just quickly show them, just
Yeah.
as a reminder. This is the parametric integration question.
yeah. So with my group, I just briefly went through it, and I said to them, look, it says on the advanced information on paper 2 for differentiation, like specifically.
Oh yes, you're right. So you were saying that on the advanced information, it specifically said for differentiation, differentiate parametrically.
It says differentiation of curves defined parametrically.
But on the paper 1, advanced information, for integration, it just says method of integration and it didn't specify which one. Exactly. And there's loads of different types of integration. So they could have been more specific with that one.
And I just thought if they bothered to mention it for differentiation parametrically, so if the integration one came up, you wouldn't think that they
that would have been a quite big help.
So when it came to method of integration, when we were going through papers, parametric, we did briefly cover it, but not to that extent, which I would want.
Right, very quickly, there were 16 items on the advanced information, 16 items, 16 different topics, and there were 16 questions.
Yeah,
so every single question was, so the questions weren't merged together, in any way. So what can they expect before we go through the actual paper and some of the questions, won't go through the exact solutions, but we'll go through the skills that's required, okay? Yeah. Are we assuming now for paper 2, how can they look forward to it? And are we assuming that every single topic here will have its own question?
Would be a question.
Each bullet point would be
16 bullet points in paper 2, so I would say expect 16.
And same for mechanics, and we won't know about.
Well, mechanics again. There's 5 usually, 5 or 6.
Yeah.
6 I think in
okay. All right. But let's stick to the pure now. Take us through the paper, okay? Just take us through the paper. Just very briefly, the skills required on each question. So let's start with question 1. I don't know if this will show up very well. If not, if you do have access to the papers, then you can have a look at it. Well, go through question 1.
Question 1 is just transformation of graphs and the use of modulus, the modulus sign. So you've given a coordinate of a point, and it just is undergo through different transformations, so it just match up.
Pretty straightforward, and where the point lies after doing those transformations. 4 marks, nice and easy. Question 2. That is a very common question.
Yeah, factor theorem. We just
you were smiling when you saw that one.
Yeah, I was like, okay, that's easy 3 marks. So you just plug it in and then you solve the equation. Again, it relies on your algebra skills.
Put -2 in there, get that 0, factorize the rest. Yeah? Fantastic. That's 3 marks, 7 altogether. Yep. Yeah.
Again, it's a nice circle one.
Question 3.
Complete the square.
Yeah, I mean that is GCSE's students are doing this, and this is year 13 A-level. GCSE students are doing this now. So complete the square.
Complete the square, get the center, get the radius.
Yeah.
And for the second part, draw a diagram. I mean, usually...
Diagrams you know, a picture paints 1,000 words. Every time I come across any questions like this, I always like to put as much of it on a diagram so it helps visualize it. That's
And question B involves probably SOHCAHTOA, basic trig. If you draw a diagram, you'll see a right angle through the tangent radius theorem. And
question 4. Question 4, this limits of
I
integration.
mean, they even broke it up for you. Okay, so
Right,
it
part
says
one,
express it as an integral. Usually, there was a similar question in the past paper where there was limit sub came up and they didn't break it up.
Okay.
But here, at least they broke it up.
Yeah, and it's just 2 over x, so just put the integration sign and the 2 over x, and that's it. Part B of that, show, so actually integrating it.
Yeah.
ln,
Be
using the laws, yeah, of what would we get? We'd get ln, 2 ln
get
x,
2 ln x and then substitute in the
the
limit.
6.3 and
uses
the,
laws of logarithms
to put them
simplify.
together to get ln k. Question 5.
There's another one I smiled at.
Yeah.
I read it through and I go, you know what? This is just linear simultaneous equations. Like this is GCSE, I would say.
Yeah, plug them in.
So plug them in. You set up your simultaneous equations, solve it, and then test it with the.
And can you see the, you know,
values.
this part B, evaluate, giving, well, there's 2 marks here and there. How many marks in total, by the way? 6 marks here. We got 3 marks here. That's 9. We had the 5 here, so that's 14. And we had the 7, wasn't it, from earlier on? So that's like 21. 21 marks. And where are we up to? We're on question 5. Yeah?
Yeah, 21
5
marks.
questions,
21 marks. Let's, what is it, out of 100, wasn't it, this paper?
Yeah.
Yeah? 21% we're looking at. Is that, what kind of grade would they give for that banding?
1%, you're looking at probably an E/D.
Yeah, they've got an E/D.
At least they
That's
passed.
5.
Would say
That's
at
a
least-
pass. Already 5
first 5
questions,
question, you
and there were
can
5 easy questions. So for a student who has had a difficult 2 years, you know, they've missed so much learning. You know, with schools being in lockdown and a lack of their own motivation. That's good enough for them to get a pass. But obviously,
I'm sure people.
yeah, they want more than
a
that. So let's
pass.
continue. What's question 6?
Okay, question 6 is
Yeah, go on. I just showed
right.
them.
So you were given a graph. You're given the coordinate of important points, and it says find the set of values where the gradient is decreasing. So we know that it's sloping down, and you just read off the graph.
Yeah. Okay. Very straightforward.
one
6
easy
more
mark.
marks. So you can keep adding to that.
And then-
question 7. Proof. Now you said like questions like this might trick a
we
few
go back
people.
to-
Or do we want to go back?
There's a bit more.
Question 6. Going back to question 6, guys.
Part B, find intersection. So when y equals k, it's a horizontal line. You want to cross it once. Look at the wide ranges. You can easily work it out. And question C, factorize. Find the equation and leave your answer in factorized form. So you're given the roots. And you know it's a cubic. It cuts through, so it's a single root, and it bounces off. It's a repeated root. So you can get your
you can
factors.
get all your factors.
The only thing is, there's always going to be a coefficient at the front that may make the equation different, and that's you use the maximum point and substitute that in, and you work out what that coefficient would be.
Straightforward. Right. Question 7. Now this question, the proof one, proof by contradiction.
Yeah, I mean, if you're not, most people are not confident with proofs. So I would say, okay, for now, leave it to the end. Like
5
there's so many
marks,
other
just-
marks,
yeah, 5
so
marks.
much other marks you can gain on. I would say, if that's going to take you too long, just skip that. Come back to it at the end.
Okay. Very quickly, let's just quickly go through the rest of it. Obviously, we can't do this for every single question. I'm sure you'd appreciate that, guys, who are viewing. But if you just quickly go through 8 was okay. I mean, look, question 9. What do you think of question 9?
Question 9 it says it's a parallelogram, so opposite sides are equal.
Yeah, I mean-
and to show this is a rhombus, we have to show that the size of the two are equal. So PQ and a QR, work out the magnitude of those. If to show that they're equal, therefore it must be a rhombus, because if you're given that it's a parallelogram and you're shown that all the sides are equal, then rhombus.
Excellent.
An area of the rhombus.
Once you've got those
area of a
lengths.
triangle times 2.
That's it. All right. Question 10. That's a common
There's
question.
another nice one. 'Cause
That's a common question
it's-
too.
It was also in the a lot of the, practice questions. It comes up modeling with exponentials. So again, you just substitute values in and use the model given.
Right. 11 onwards, it starts getting into the more calculus, business side of A-level mathematics.
Again, question 11 again is just solving equations, finding the intersection points. You equate them, solve the equation. You get solving a cubic for. Well, part A just says verify. Now I looked at. Hang on. If you're verifying it, a coordinate, usually it's just one marker.
Let me just show
But
them.
this one they're giving you 2 marks.
Yeah. go on.
All I'm saying is you just substitute half into both equations and show that you get the same y
No,
coordinate.
these guys probably can't even see. I'm probably holding up a blank piece of paper. They're probably wondering, I can't see the questions. If you can't see the questions, I'm sure there's loads of resources out there where you can see, people have posted
Like,
it.
look, 2 marks just to substitute half into both equations, show that they
I
intersect.
mean, the marks, I mean, I
would-
think it's a
that should
decent
be-
paper. Like, I
so-
mean, I think this is actually a very decent paper. If what did they give? What was the grade A last year? I mean, 2019. It was quite low. It was around 56,
52, I think.
52%, yeah. So the grade boundaries have been quite low for the new spec A level anyway. And already, a lot of them can save a lot of marks. I mean, look at question 13 here.
Well, we skipped
I
question.
know.
Question 12 is just integration by parts.
Yeah,
so-
integration by part. But if you look at question 13, I mean, arithmetic sequence. and
It's a good one. I mean, the proof of the summation of sum formula.
Yeah.
If
a
you,
nice
if you forgot,
question.
if you forgot how that's done, then at least you can use that on the next part. Of the
I mean,
question.
and if you look at question 14 too, these are lovely questions. Cast diagram.
Yeah,
So
even question 14, like use the addition rule to open them
Yeah,
up
open
and
them up.
simplify, and it will get you
yeah,
get
let,
into
me just, let
10.
me just show them again. I don't know how well this is panning out to be, but yeah, if you can see that, look.
Yeah,
so
just
use the addition rule,
on both sides
open them
and
up,
simplify into 10.
and then
And then use
whatever-
that formula and for the next part and
For the
solve
co-
the
for
equation.
the-
Probably end up solving tan 2x.
Yeah, probably tan
Or
2x.
tan 2 theta in
yeah,
that case.
and then using the cast diagram to find the values. Yeah.
And then look at the answers.
All right, and then we've got more of our
So common
differentiation.
questions
stationary
and modeling
points.
modeling with
Yeah,
differentiation.
go through that question 15 here. Yeah, so go through that very quickly.
Yeah, so you were given the volume of that slice of
It looks like a cheesecake, but
the size of cheesecake. So work out the cross section area. So it's a sector. So half theta r squared in radians, area of sector, times by the height gives you the volume, and your volume is given, and you rearrange it and make h a subject, sub it into the surface area.
you know what? And now we go to question 16. And this is, by the way, a very common question. Once again,
Yeah, it's-
question 15 was a very common question. You have different shapes each time. You have
Yeah.
different volumes each
It's
time.
always
That's
do
it.
surface area and volume. So
All right, and then we come to our last question, 16, which we already mentioned, parametric. But do you want to quickly take them through like what steps they'll do?
yeah, I mean it's a parametric integration. So formula is y dx dt, integration of y dx dt. So you're given y in terms of sine and in terms of sines. You just have to differentiate the x with respect to t. So, and x is equal to 8 sine squared t. So differentiate that function, stick them together, expand, simplify into the expression they want you to have inside the integral, and change the limits. And there you go. That's 5 marks.
All right. Okay, done. Give them some advice now. What would you say? How do they prepare for paper 2?
Right. For paper 2, I would say look at the topics listed.
A lot of comments I'm getting is, can you do a predicted paper for A-level? Now, with the predicted papers, it's very hard to predict these
I
questions.
think if you have the basic understanding of those topics, then you should be good enough, to at least get half the paper done.
Yeah, half the paper.
So
But we will try. We'll try to put something together in the next few days.
Yeah, I think
and maybe the most popular, common questions, we'll take a few of those and put them together in a
just looking
paper.
at this, the mid bullet point here is use of trig functions. So usually it's the
So that's the R cos, R sine,
yeah. So it's
expansion.
two
and you compare.
sums of sines and causes. You turn into a single trig function using the R alpha.
And then you got differentiation from first principles. So that could be like,
Could be a polynomial, or could be a sine cos. But
sine cos.
it's more common to be a sine or a cos.
Yeah.
But I haven't seen a tan come up.
we haven't seen tan cap. So that might be something you might want to do. That's a good one.
Integrating tan.
Yeah, area under a curve. We've got lots of these videos, by the way, on the
That's quite
channel.
ambiguous. Area under curve.
Yeah, so it could be between 2
Ambiguous,
points. Yeah, ambiguous, yeah. But we have a lot of these topics, and on the videos that we...
Make sure you take that off.
we have a lot of these topics, and on the videos, we do exam questions for each of these topics anyway, like the
Yeah.
trapezium rule and area under a
the
curve.
trapezium rule.
Yeah.
But with most trapezium rules, they always say at the end, work out the exact answer. So again, you might have to use integration, method of integration for
All
that.
right, but we'll try to do something for you guys, yeah? I hope you enjoyed this review of the Edexcel Paper 1, and we will try to review Paper 2 when it's done, and obviously the Statistics and Mechanics.